Hello, good morning, good afternoon, everyone. Today I am going to introduce to machine learning, one of the most excited and transforming technologies of our time. What is the machine learning? First of all, in simple terms, we will see the machine learning. What is the machine learning and why we are using the machine learning? Machine learning is a branch of artificial intelligence that is enable computer to learn from the data and improve their performance without being explicitly programmed. Machine learning in a simple way, it is a simple term. Machine learning and enables in machine learning enable computer to learn from data without being explicitly programmed. Traditionally, if we want a computer to perform a task, we have to written a detailed step-by-step instructions. For example, if email contain a certain keywords marks as a spam, if a temperature drops a 0 degree, show a false warning. But what if the rules are too complex to define? What if the others we will use the machine learning and what if the rules are too complex to define it is? What if there are thousands of billion of patterns that were a machine learning we are used in a patterns instead of the program rules manually we? The first is a provide a data. Second is lets the system learn pattern from the data, allows it to make a prediction or a decision based on its learning. And the more complex data is the process of the better it's become what it means. When we say ML system improve a performance through experience. How does a machine learning works? A machine learning as a high level machine learning follow the three steps. First is the data collection, second is the training the model, third is the prediction or a decision making. These are the machine learnings we are used in our daily to daily life. Okay. The machine learning is a broadly categories in a three category. First is the supervised learning, second is the unsupervised learning, and third is reinforcement learning. There are the three types of the machine learning. First one is the supervised learning. In a supervised learning, the model is a training, use the label data. Each input has known as a correct output. Example, email label and spam or not spam. Image label is like a cat or dog. There are the two different categories we are used in a machine learning. Machine learning is used uh, for the improve the inputs as known as a correct the output. The system learns the relationship between input and output. There are the startup of the learning the relationship in how we are give input and the output we are defined. The say how to common uses is the fraud detection, credit scoring, medical diagnosis. We are using a supervised learning. Unsupervised learning is the data is a non-label. Identify unusual transactions. This is the widely used in a marketing and data analysis. Reinforcement learning. In a reinforcement learning, the model learns by interacting with an environment. It's improved to maximize rewards. This is the commonly used in a robotics and game AI. The third one is we are using a reinforcement learning. The reinforcement learning be like the action and reaction. We uses like customer segmentation, demand forecasting, personalized marketing, and chatbot. They are the uses of the machine learning. What are the unsupervised learning? Today we will explain the unsupervised, the main topic of today's seminar. Unsupervised learning is a work or the unlabeled data. Unlabeled data means the data are not a categories and not a defined by a particular names and labels. That's why we are using the unlabeled data. Second is the no target variables and output is given. Okay. There is a no target variables, no correct answer provides, and no predefined output. Unlike a supervised learning where we will tell the system what the correct answer is, and here we simply give it the data and allow it the explorer. What is mean the simple terms? Imagine giving a machine learning data of customer information. The age is a location and purchase a history browsing behavior. But you do not tell it who is the premium customer, who is the likely to churn, and who belong to which category. This system task it is to analyze the data and identify the hidden pattern its own. There are the third is that the system tries to identify hidden patterns in the data. What is meant by this? It look like the similarities, difference, structures, and relationships, and then it's the group of the organize the data automatically. How does it work? Unsupervised learning is the mainly focus on the two major tasks like a clustering and association. That way we are understanding the hidden patterns from the data by using the algorithm of the unsupervised learning. It is find the similarities and structure the automatically. That's why we will understand the similarity structure automatically. The unsupervised learning like unlabeled data and unstructured data, there is a no target data, there is the no correct answer provided and no prediction. That's why we will use the machine learning topic is the unsupervised learning. The similarities and structured data means there are the most similarities we will use in the data variables. Hidden patterns like this finding the hidden patterns and predict the futures based on this dependent data. That's we were using the unsupervised learning. Example of the understanding of the unsupervised learning we will see and explain its belong to this page. The firstly, let me explain the unsupervised learning very simply and practical example. Example to understand the image. Imagine you are working for the retail company. Okay, you have a large data set of the customer information, including like age, spending habits, and purchase history, without being told which group they belong to. Okay, what this means? But there is the important part you do not have the labels. You don't know who is the high value customer, who is the discount shopper, who is likely to buy frequently. There is a no predefined category. That's why we use the algorithm to do. Insight being the opposite of the each customer is the algorithm analyze the data and start identify pattern. It might discover a group of the young customer who spend a small amount but buy frequently. A group of the middle aged customer who mark purchase occasionally, a group of the customer who only shop during the discount. This all these terms we are dependent on the customer based on age, spending habits, purchase history. There are the three categories we are discussing on the unsupervised example. Notice something important. We never told the system these are the group exists. The algorithm focus this as the similarities automatically. What is happening behind these scenes? The model compare customers based on similar age, similar spending patterns, and similar purchasing frequency. It means how close or similar the data points are the groups the one of look alike. This process is called as clustering. Real world connection we have seen in these examples and now we will move to the next point. It is of why we are using unsupervised learning. Okay, there is the questions we are asking why we are using the unsupervised learning for the future predictions and what is the importance of this. In the real world, most of the data come not with the labels. Customers transaction do not target at loyal high risk. Medical record does not automatically say this is type A, type B, and others. And user behaviors logs do not label people as engaged and inactive. Organization collect the massive amount of the raw data every day but without a clear output. Unsupervised learning help us make a sense of this raw information. Firstly, the label data is expensive and time consuming. What is meant by the second point? Label data is expensive and time consuming. Creating a label data is often a required human experts, manual review, quality checks, and significant times money. For example, doctor labeling medical image, analyze the review fraud cases, and teams categorize the customer feedback. This process is a costly and slow. Unsupervised learning removes the dependency on a label outputs and works directly with available data. Helps it to discover the unknown patterns. The third point is a help discover unknown patterns. Sometimes we do not even know what the patterns we are looking for. Unsupervised learning helps uncover hidden customer segments, unexpected relationships, emerging trends, and anomalies in a system. For example, companies like Amazon analyze the purchasing behavior to uncover new customer segments that we will learn for a predefined data. These algorithms might reveal groups we did not even think existed. And the last one, the fourth point, useful for the exploratory data analysis. Before the building of the predictive models, data scientists often explore the data. Unsupervised learning helps to understand the structure, identify clusters, detect outliers, reduce data complexity. It gives insight to what kind of the data we have, how variables relate, whenever meaningful group exists. It's like the exploring a new city without a map. First we observe, then we understand. Key keywords we are audience. Need a unsupervised learning because most real world data is unlabeled. Labeling is expensive, it reveals a hidden insights and its system supports data exploration. In many cases, is the first step in understanding the complex data. Okay, this is the why we need to unsupervised learning. The next one, the type of the first algorithm of the unsupervised is the clustering. And what is the clustering and why we are using the clustering for the data, unlabeled data. Okay, we will see that clustering is the process of the group data points together. Now let's understand one of the most important concept in unsupervised learning is the clustering. Clustering is the process of the grouping the similar points in data. In simple word, we will see data points that are similar are placed in a same group. Data points that are different are placed in a separate group. Each group is called as a cluster. Okay. The second one point is the key idea behind the clustering. Objects in the same clusters are the more similar to each other. The basic principle is objects in the same cluster will more similar to each other. Objects in a different clusters are less similar in a dissimilarity. Similarities can be measured based on distance, mathematical distance between a data points, features, age, income, and behavior pattern in the data. The algorithms we will use in unsupervised learning close to the related to the points and group them accordingly. Simple example for the explanation is the image a dataset of the customers with age, annual income and spending score. The algorithms may from clusters like young high spenders, middle age moderated spenders and older low to spenders. We did not tell the system how many types of customers exist. It's a discover the structure automatically. Real world application clustering is a widely used in business, customer segmentation, and target marketing data. This is the unsupervised learning, and the first we will see the clustering. Application of the clustering we will see there are the first is a business, healthcare, technology, and otherwise. First one is the customer segmentation. Why we are using the customer segmentation and what is the uses for this the data apply. Now let's explore where the cluster is actually used in a real world and clustering is not just a theoretical concept, it has a powerful practical application across many industries. Customers segmentation. One of the most common application of the clustering is the customer segmentation. Business group customer based on age, income, spending behavior, and purchasing history. This is help companies to design a target marketing campaign, offer a personalized discount, and improve the customer retention. For example, platforms like Amazon and Netflix group user with the similar behavior to personalize recommendation. Instead of they treat all the customers the same, companies create a cluster and tailor the strategies accordingly. The second one is image segmentation. In a computer vision, clustering used for the image segmentation. This means the dividing an image into different regions and based on the similarity, color, texture, intensity. Application include medical images, object detection, satellite image analysis. These are the application for the image segmentation. For example, in a healthcare clustering can help separate healthy tissues for the abnormal tissue in scans. Third one is the social network analysis. Clustering helps identify communities within the social network. For example, the group of the users with the similar interact communication that frequently we were using to interact influencer group also. The platforms like which one is a Facebook use a similarities technique to detect communities and improve the connect recommendations. This is the platforms we are using and analyze the data for daily to daily. This helps to understand how to information spread and how to people connect. Medical diagnosis in a healthcare clustering can group of patients with the similar symptoms, identify patterns in disease progress, detect the subtypes of the disease. This type helps the doctor improve diagnosis, personalize treatment, and identify risk group. Sometimes clustering reveals the pattern that were not previously known. And the last one and fifth one is a fraud detection. Clustering is used in a fraud detection. It helps to transaction the patterns and used for the detect the abnormal users behavior. We will use this for the detect the most customer behavior similarity, but one transaction pattern is locked very different clustering can fly. This is used for the financial institutions used to reduce the fraud and improve security. Key takeaway for the your audience: clustering is a powerful because it groups a similar data, reveals the hidden structures, support the better decision making, and work without the label data. From marketing to medicines to cybersecurity, clustering play a crucial role in modern data-driven systems. Likely we can now prepare the final summary slides. We are entire entire the unsupervised learning sessions. The next one is we are using the next topic of the unsupervised learning. This is the K-mean clustering. Okay, what is the K-mean clustering and why we are using it? Is now we will discuss the topics is the K-mean clustering, real world application, and this is the where. Okay, cluster segmentations. Clustering is a widely group of the customer based on the age, income, spending, and others. But the K-mean clustering is a different from the clustering, and they we will see what is the K-mean clustering. Okay. Now to move one of the most important clustering is the K-mean. It is a simple, efficient, and work well practical problem. The main idea it divides data into a clay clusters where k is a number to some before training. Each data point belong to the cluster with the nearest central. What does k mean? The letter k represents number of clusters you want to create. For example, if k equals to 2, the data will be divided into two clusters. If k equals to 3, the data will be divided in three clusters. And if data equals to k equals to 5, the data will be divided into five clusters. The value of the k is predefined by the user. This is an important point. Unlike some algorithms, k-mean clustering requires you decide how many clusters you want. How does k-means work? Here are the step-by-step process. Step first. Choose K. Decide how many clusters you want. Initialize the centroid. The algorithm randomly select K points in the dataset as the initial centroids. The centroid is the simply and the central points of the cluster. The step 3 is the assign the data points. Each data point is assigned to the nearest centroid based on the distance, usually Euclidean, and this creates a temporary clustering. Update the centroid, the algorithms re-allocated the center of the each clusters by finding the average of all the points. In that cluster, the repeated of the fifth point is of repeated. Step 3 and 4 are repeating until the centroids are the stop charges and all the charges are the very small. Okay. The steps in the Clemens clustering: choose the number of the cluster, select random centroids, assign a point to nearest centroid. We will step by step choose one by one step and discuss about the Clemens clustering works. First is choose K. Decide how many clusters you want, what you want, and you want to how much clusters. The number equals to K. Initialize the centroid. The algorithm is a randomly select the K points in a dataset as initial centroid cluster central. A centroid is simply the central point of the cluster. Assign the data points, and the data points is assigned to the nearest centroid based on the distance, usually Euclidean distance. They create a temporary cluster. Fourth is update a centroid. The algorithm is the centroids of each cluster by finding the average of all points in the cluster. And the fifth one is the repeat until a governance. The step 3 and 4th is a repeated until the centroid is the stop changing or the changes become a very small. At this point the cluster as a finalized. Key concept: distance by centroid. K-means work based on distance, not as the how many Ks and what you want. Each data point join the cluster whose centroid is the closest to it. So, object close together, same cluster, object far apart, different cluster. The algorithms try to minimize the total distance between the data points and the cluster is the centroid. The next one is a simple example for this is the age and annual income. If you set k equals to 3, then the algorithms may perform cluster first, cluster second, cluster third. The cluster first is the young and low income. Low and young income, and there is the second one is the middle age and medium income, and third one is the older and high income. Why the claiming clustering is a popular? The k-means is a popular become it is easy to understand and it is the computationally efficient. It is work to for the large data set. It is simple to implementation, and that's why we are using the claiming clustering. That's why the widely used in the customer segmentation, image comparison, market analysis, and pattern recognition. Key takeaway for your audience: this is the most clustering algorithm, and these are the divided data into a click to predefined clusters. There is the based on the distance centroid and iteratively update cluster central. There is the next point we will see hierarchical clustering. The hierarchical clustering is the build the clusters step by step in the two types, and there we will see in a next point. Now the explain of the hierarchical clustering, discuss the another important clustering technique. Hierarchical creates a tree-like structure of the clustering. Instead of the choosing the number of the clusters at the beginning, it gradually merges of the split clusters. From a hierarchy, the smallest largest group. This makes it as very useful when you do not know how many clusters you want. There are the two types of the hierarchical clustering. There are the two main approaches. Algebraic clustering is the bottom up and the divisive is the top down. What is the algorithmic bottom up clustering? This is the most commonly used in a method. It's work like this. Start with each label data, its own clusters, find the two closest clusters, merge them together, and the fourth last one point is a repeat until all the data points are grouped into one large cluster. So it builds cluster from the bottom up. Think of like the forming a group into a classroom. First students is a pair up and then pair join other pairs. Eventually the whole class becomes a one group. This is the important example for the bottom up clustering. The next one is a divisive clustering is a top down. This work in a opposite direction. Start with all data points in one large cluster. Split the cluster into smaller groups. After the group is divided into a splitting, the continue dividing until each data points become in the own clusters. So it's break clustering down from up to the and top to the bottom. You can explain like a breaking large organization into departments, then into a teams. Visualization diagrams. What is meant by the visualization diagram? The hierarchical clustering is usually visualized use a diagram, a tree-like diagram that show how to cluster is a form and the what the distance cluster is a merge or split and the hierarchy of the relationship. By the cutting the diagrams at the certain height, you can choose how many clusters you want, and this make a hierarchical clustering very flexible. Key difference from the k-means clustering. Compared to the k-means, it does not require the predefined k at the start. It provides a clear hierarchy of the clusters. It works well for smaller data sets. It is compulsory more expensive for very large data sets. Now we will understand the next one point is a DBSCAN. Okay, let's understand the point of the DBSCAN in the unsupervised learning. The DBSCAN we will use to stand the density-based spatial clustering of application. The full form of the DBSCAN is the density-based spatial clustering with a noise. N stand for the noise. Unlike the k-mean and hierarchical clustering, the DBSCAN is based on density, not a distance from the centroid or hierarchical merging. What is the DBSCAN? The DBSCAN is a group together data points that are closely packed, meaning are areas where there are many points close to each other. At the same time, it identifies points that lie alone in a low density regions. Mark them as a noise or outlier. This makes DB scans very powerful for a real world messy data. Core idea density based clustering. DB scan from the cluster based on the two main parameters epsilon and the mean pits. This is the example distance between 2 points and the maximum number of the points required. The key advantage of the DB scan does not require a predefined K. Unlike the K-mean, we will need to specify the number of the cluster in advance. Can detect the noise and the outliers. Very useful in a fraud detection and anomaly detection. Work well with the irregular cluster shape and K-mean struggle with a non-spherical cluster. but DBSCAN can handle them effectively. Simple example for the explanation. Imagine a map without a location that of the customer. In cities and points are very close together, high density from cluster. In rural area, points are the scattered, low density marked as a noise. DBs can naturally separate dense regions without a needing to know how many regions exist. Real world application. DBSCAN is the commonly used in a fraud detection, anomaly detection, and geographical data analysis. Image processing and network security. Important terms for the unsupervised learning we will use and why we will understand this. Important terms like the three terms we will see in this. Okay, the terms is help to measure the strength of the rules that algorithms discover. First is the support. Support is means measures how often an item set appears in the dataset. Support K to Y. Number of transactions containing both X and Y. Total number of the transaction. In simple words, out of the transaction, how many contain that combinations? Example, if the 100 customer bought together and 20 bought both bread and butter, the support for the bread butter is 20 by 100, 0.2 or 20%. Confidence. Confidence is a measure how often the rule is true given to the condition. Formula confidence is the x to y, support x and y and support x. In simple word, if the customer buys an X and likely are they to also buy Y. Example, if you 40 customers and there is about a bread of the 20 also about the butter is the confidence for the bread and butter is the 20 by 40 and zero point 0.5. Okay, this is the 50%. And third one is the lift. At what is meant by the lift? Okay, there is a lift is a difference term and lift is a measure the better that rule compared to the random. Okay, the first one is the lift is the confidence and supports. In a simple word, does buying X increase like a likelihood of the trying Y compared to the just a random buying? If it's the 30 of the customer buy a better and a confidence. There is the bread and butter 50%, then the 0.3 is the 1.67. Key takeaway support is the how often items occur together, confidence is how often rule is correct, and lift how strong the rules is compared to the random chances. Association rule running. Association rule is like we use why we are using there for the next one. Finding a relationship between a variables using a market based analysis. An example, if the customer buy milk, they also buy the bread. A prior algorithm. Identify the a prior algorithm. A prior algorithm is identification and we are using for the identify the patterns. This is the algorithms identify frequent item sets in a transaction data. These item sets are combination of items that appear together often. Once the frequent item sets are found, rule can be generated, example bread and butter. How it's work, a prior work using a support threshold. Scan the dataset to find a single item that meet the minimum support. Combine this item to from large item sets. Eliminate infrequent combinations that do not meet the support threshold and repeat until no more frequency item sets are found. Key concept and a support threshold. The support threshold is the minimum percentage of the transaction in which an item set must appear. Only items set above the thresholds are considered frequently. Example, if the minimum support 20%, only item sets appear in greater than 20% of the transaction are kept. Simple example, imagine a supermarket dataset. Items bread, milk, butter, eggs. Transaction is 100 purchases. Find the single items with a support is greater than 20%. Combine it to the pair and a breads and butter. Eliminated pairs that appear in the less than 20 transaction contains for a triplet. Only this is we are using this example. Application of the association, retail recommendations, system online shopping suggestion, cross-selling strategies and inventory management. Dimensionality reduction is the reduce the number of the features in the dimension reductions, and there are the users of the data to how to use. Now the limits of the dimension reduction is the process of the reducing the number of the feature variable in the dataset. The goal is to keep to the essential information, remove or redundant or irrelevant features, make the analysis and computation faster and more efficient. Why do we need it? High dimensional data is a complex, more feature, harder to visualize, harder to model. Example, a dataset within 1000 features can be difficult to work with. Redundant or irrelevant features. Some features don't add values or are correlated with others. Removing them is a specifies the model, improves computational speed, fewer features, faster training, lower memory uses. Reduce the overfitting, lazy noisy data help the model generalize the better. Simply analogy, imagine you want to describe the city and friends. You could not every single street building and shop. Too much information. Instead of the summarize with key district and landmarks roads, important information preserved. Principal components analysis (PCA) is the most popular dimensionality reduction technique in unsupervised learning. They are the PCA is a stand for principal component analysis and it is used to dimensional reduction city. That's why we will predict the future and convert the variables into principal components. Keep maximize variance and information we are using the principal component analysis. Real world case study and example we will see. Customer segmentation. We will see the customer segmentation. Companies group customer based on there are the three groups we will see. First is the spending behavior, demographic preference used for the targeting market. Spending behavior means how much customers use and how many data they are defined to spend. That we were using the spending behavior. Demographics like the how much their data is related and how much analyzing users. Preference if we are give advertising to a particular data, there is the any preference and how to use this. Fraud detection. Detect the unusual transaction, identify abnormal patterns and use in a banking system. Transaction in a daily to daily banking, we will use the detect a lots of data. They are the fraud and fail. But how to identify abnormal patterns? Like there are the absence of the data and classification of the particular data set as a customer. This is the abnormal patterns we will see in a fraud detection. Used in a banking system. Banking is the most important and there have a lots of is a online transaction. The people money is goes on the other accounts. This is the banking system fraud detection happen because the irregular data is and unlabeled data we will see. The third one is the recommendation system. The recommendation system is recommended by the authors and referenced by the authors. like a used by the Amazon, Netflix, and YouTube. What do you see and how to your history, what you want. They recognize and they predict the futures, what you want to see on your YouTube, Amazon, and Netflix, like a web series and others horror movies based on your previous data and based on what you want to see on Netflix. They recommended you to what your interest in which components, and this interest is depend on the based on what the factors you search and what the factors you like on the any videos, like on the any subscription, and like on comment on and text searching any particular content. They are recommended the same thinking in a multiple times. Healthcare applications like a medical analysis, disease pattern identification, medical image clustering, and patient risk grouping. Healthcare diseases pattern identification. Based on your data and based on your other applications, what the preference the patients is want to disease and how to recommended their next recovery process. Medical image clustering, like the data sets are clustered based on the other factors like their data sets and their patients. Patients risk grouping means patients age, patients factor, patients others like other diseases based on the applications like prediction based on the unlabeled data. This all the real world example we will see in lab. What is the challenges we will see in a label data? Choosing a correct number of cluster, how many groups you want and how many clusters you want. Handling a high dimensional data means their dimensionality, like how much their preference, expensive, this data is how to handle. Scaling the large data sets. The data sets is scaling by their grouping, and all these data sets are scales on their based on the few data sets. Interoperability issues, like their interconnections between the data and issues based on the unsupervised and unlabeled data. That's why we will see in the challenges in unlabeled data. And next we will predict the prediction based on the machine learning algorithm. Future scope this self-learning AI system. AI is the based on the machine learning, and all the machine learning algorithm is depend on the AI feature. Big data analytics, deep clustering techniques, and integration with the neural network. Neural network is deep connected with the deep learning, and deep learning is the based on the neural network connections for the neurons and help to the prediction of the data. Big data analytics, the collecting of the large data sets and analyze the data, collect the data sets, patterns recognize and predict the future. This the future scopes we will see in the machine learning and unsupervised learning. Industry uses cases. Companies use the clustering for sales analysis, customer retention, and product optimization. Advantages: work without the label data. It's not inexpensive, and most is the labels. Discover the hidden insight useful for the data exploration and help to and pre-processing data. That is the advantages we will see in the unsupervised learning, and this is the pre-processing data we will use for the unlabeled data. Difficult to evaluate accuracy, result may be hard interpreting, required to the domain knowledge and maybe produce a meaningless cluster. These clusters we will use for resulting may be hard to interpret, requires domain knowledge of the particular data set. We have the unlabeled data, that's why we are not a efficient knowledge for the particular data set, and maybe produce a meaningless clusters, and like you used to ungroup the data by based on their data sets. Conclusions is the last one point. The unsupervised machine learning play a vital role in data sets, discover the hidden insights, business intelligence, advanced AI, and it is the foundation of the modern data sets. This is the data sets we will use, and it is the foundation for the data. Discover the hidden insight, business conclusions. The unsupervised learning is the most important for the machine learning algorithm, because the AI is a depend on deep learning and also the machine learning, that we will see how to detect the data and why we are using. Discover hidden patterns based on the data, what data you are used and the data we will see in the next one. Business intelligence is a BI, and BI is a very powerful tools for the prediction of the new imaging data. Advance of the AI system is are the also data sets like a LLM model, deep learning models, and others models like computer vision and the image predictions. It is the foundation of the modern data science of the unsupervised learning. This is the all we will see and how to use of the data in the data sets. That's are the use of the data sets.